Hi everyone, welcome to G World of Academic Physics. Today we will discuss some of the important questions of the electrostatic that can help the student to enhance their ability of thinking. Look at the question 1. This is a non-conducting rod having mass m, length is L. The rod is pivoted at the point, this is the pivoted point, exactly mid of the rod it has pivoted. And the electric field has supplied in these directions. The direction of the electric field will be like this. And if you look at this rod, the one half of the section of the rod is positive, having line charge lambda, and the other half section is line charge density is minus lambda. This half sections means if total length is L, this L by 2 length, that will be a positive charge having line charge density is lambda, and other sections, this other half having negative charge having line charge density is minus lambda. The question is asking if a constant electric field is provided like this, which is makes an angle theta with this rod. The question is asking find the time period of SHM. Find the time period of SHM. Now the question has arisen, can this SHM will be happen here? Let me think about it that how this SHM is happening. If electric field is like this, let me think about it little in a better way. Let me redraw. This is my questions. This is the exactly the pivoted end. When this kind of rod questions is offered to us, we know this rod is an extended body, so we have to think about an element. If I look at an element from x distance, I consider a small element. This small element length is dx and charge is dq. If I will consider from x to dx, one small element is here, so charge is dq, and electric field will be this directions. So what is the direction of the force in these sections? The direction of the force, it will be like this. This is my df. Due to this small element, the force will be like this. In the similar fashion, if I look into these sections, similarly I will consider a small section x. I will consider an element dx. And this is positive charge, and here the negative charge will be dq. Electric field will be like this, and positive charge the force will be like this, and negative charge exactly the force will be like this. So if you will see, the net force on this system is 0, but due to this couple of force, a torque will be generated. A torque will be generated. So what will happen? This rod will rotate around these directions. This rod will be rotated like this. This is pretty clear to everyone, I think. Yes, this rod will be rotated. And what will happen if you look at exactly this scenario? This force this direction, this force this direction. Due to that, a couple will be generated, couple of force generated, a torque, and this rod will be rotated like this. So when this rod exactly reach at these situations, what will happen? If little bend, this rod will be come to these sections, the force will be reversed. So what will happen? This rod will make to and fro motions exactly at this point. Because in the upper section, it will be rotate like this. In the lower section, it will be rotate like this. So exactly at this point, it will make to and fro motion. So definitely SHM will be exist. The question is asking find the time period of SHM. So in this kind of questions as given, I consider a small distance x, I consider a small element having charge dq and dx. So I will write my force expressions. What is the expression of the force? What I will write here? We know that this is df. I will write my torque. The torque can be written as, very carefully I will write the, due to this small force, how much torque will be generated. Torque can be written as df, force into perpendicular distance. If this is x, this angle is theta, can I say this is the perpendicular distance? Yes, this is x sine theta. I hope the scenario is pretty clear to everyone. So df into x sine theta. Yes, this is the torque due to this small element. df can be written as e dq x sine theta, and E is E because the electric field is here, constant electric field is moving like this. So I consider this electric field is E, and dq can be written as lambda dx, and this is x sine theta. Little arrangement here, E lambda sine theta, this is x dx. This is the torque generated in the upper half sections. I am talking about these things. If I will go for integrations, I will get the net torque about this upper half sections. So I will do the integrations. If I will do the integration, this is the tau net in the upper half sections. Upper half sections we am talking about this. So this is E lambda sine theta, and this is nothing but integration of x dx. And what should be the limit? If I will consider this upper half, this, if I will consider the element here, this is 0 and it is goes up to a maximum length of L by 2. So 0 to L by 2, because this rod, this section rod length is 0 to L by 2, the length is L by 2. So if I will proceed in similar fashion, E lambda sine theta, and this is x dx, integration is x square by 2, and this is what, 0 to L by 2, and the expression is coming E lambda sine theta, x square integrations here it will be 2, this is L square by 4 and 2 I will get 8. This is the upper section, I will get the tau net. But if you are looking for the symmetry, this upper section torque is this much, E lambda sine theta L square upon 8, and this section torque will be also the same thing. So I will get the net torque for rod, complete rod. Can I write, it is nothing but 2 into E lambda sine theta L square upon 2, L square upon 8, because this is for one half of the rod. If I will think about the complete rod, I will must multiply a 2, because this section I have to also include it. The expression is coming E lambda sine theta L square upon 4. If I will consider theta is very small, this sine theta is equivalent to, if theta is small, my assumption here will be theta is small. Can I say sine theta is equivalent to theta? Yes, someone can say like this, sine theta is very, if theta is small, sine theta is equivalent to theta. So what is the expression of tau net? Tau net will be E lambda L square upon 4 into theta. E lambda L square upon 4 into theta. I hope the net torque due to this rod I can easily predict these things. Yes. Now look at the equation I can use, that we know that tau equals to I alpha. This is very fundamental things that we must know about using the concept of mechanics, that tau equals to I alpha. So tau net, can I say tau net equals to I alpha? Yes. So tau, about this point I can easily found the expression of tau is E, just look at here, that is E lambda L square upon 4 into theta. And what is moment of inertia? What is the moment of inertia? I will say moment of inertia of the rod about the mid sections. The moment of inertia of the rod about this mid sections, one can write that is ml square upon 12 into alpha. Solving this equation, I will get the value of alpha. Let me think, this is 4, this is 3, and 1 L square has cancelled. So expression of alpha is coming 3E lambda upon this is m, yes, and 1 theta is here. This is the expression of the lambda, angular accelerations. Using the equation that tau net equals to I alpha, I am getting the expressions that equals to alpha equals to, what is the expression is coming, 3E lambda upon m into theta. If I will go for these equations, one student can easily put a negative sign. If I want to introduce a negative sign, I can introduce a negative sign. Why I can introduce a negative sign? If I will think like this theta value is decreases. With the time, this theta value is decreases. If a student want, they can introduce also alpha equals to 3E lambda by m. This is minus theta, because theta value is decreases with time. And if I compare this result with the accelerations equation, that alpha equals to minus omega square theta, I can easily predict it with the SHM equation. If I'll compare with this equation 1 with this SHM equation, I can easily predict the expressions, that is alpha, this is omega equals to, let me compare these things. Yes, comparing, will get omega square equals to what? 3e lambda upon m. So omega equals to 3e lambda upon m root over. If I know omega, someone can easily predict omega can be written as 2 pi upon t equals to 3e lambda upon m root over. And what is the expression of t? The t expression is coming like this, that is 2 pi root over of m by 3e lambda. I hope this question is pretty clear to everyone. This is a very simplest questions, but these questions has give you a good level of thinking and enhance the ability of the thinking. What I said, I consider, let me think, this is a rod, non-conducting rod, having length L, mass M, having half of the sections positive charge will be here, having line charge density lambda, half of the sections negative charge, having line charge density minus lambda, and electric field, constant electric field has flows like this. The question is asking, find the time period of SHM. If theta is very small, find the time period of SHM. When this kind of questions is offered to us, we must think about a small element. From x to dx, I consider a small element. Due to the force on this small element, I said df. And this df and torque is nothing but force into perpendicular distance. This is the perpendicular distance. If this is x, this is theta, this is x sine theta. So I'll write torque. Exactly, force can be written as E into dq. This small section charge is dq, and dq can be written as lambda dx. Using this concept and doing the integration from 0 to L by 2, I reached to the conclusion the tau net on the upper half. This is exactly a symmetrical pattern. Upper half, if the expression is these things, I will simply multiply 2 and I will say that this is the net torque due to this complete rod. And I will know the equations, that tau net equals to I half, I alpha, yes, and alpha is the angular acceleration, and which I is the moment of inertia. Exactly the middle section of the rod, the moment of inertia is ml square by 12, and I will simply put the ml square by 12, and proceeding similar fashion, I got the value of alpha. I will put a negative sign here. I said with the time this theta is decreases, so it is not a bothering thing if someone will introduce what? A negative sign. And comparing with the SHM equations, I'll get the value of omega, and omega once get, it is very easy to get the time period of SHM. I hope this question is pretty clear. Let me do one more question. This can be help you the student to uplift their thinking. How the question has framed, very carefully a student has to think about it. This is a ring. This is question 2, you can say. This is question 2. This is a ring. And this ring is on a rough horizontal surface. This ring is exactly on a rough horizontal surface. This is a ring. Mass is m. A radius of the ring is r. The radius of the ring you can say r. This is a non-conducting ring having mass m, radius r. One section of the ring is positive. Another section of the ring, this section of the ring is negative. In the questions it is framed like this. And this ring lies on a rough horizontal surface. And electric field at time t equals to 0, an electric field is supplied. The expression of electric field is E naught I cap. This direction the electric field has supplied at time t equals to 0. What happened when the electric field has supplied, this ring start rolling without sliding. It means you can say what is happening, rolling without slipping. Now the question is asking, find the value of friction. The question is framed, find the value of friction. This is a very important question. It can help the student to think in a different way. Yes, it can enhance the thinking of a student. What is the question framed? One more time I want to repeat. This is a non-conducting ring of mass m, radius r, and this section is positive, this section is negative. At time t equals to 0, an electric field E naught I is switched on. Due to this, what is happening? Rolling is occurring rather than slipping. Here the pure rollings have been happening. The question is happening, if the pure rolling is happening without slipping, find the value of friction. How much friction's value in the question is asking. If this kind of question is framed, we have to think about it. First, this ring is an extended body. So what a student will think first? We have to think about an element. Yes, we have to think about an element. So what I did, I consider a small element. This is exactly, I did a small element. From theta to d theta, I consider one element. This element from theta to d theta, I consider one element having charge is dq and length is dx. This elementary length is dx and charge in this element is dq. If you observe carefully this section, if I want to redraw here, this is exactly a section I want to draw here. This is theta to d theta. I consider one element. This is dx and charge is dq. If you observe very carefully, the electric field is like this. So this is positive. So definitely df, the force on this element will be this directions. Similar way, if I'll think about these sections, a small element, if I'll consider here, this small element and electric field is moving like this, but this small element from theta to d theta, if I'll consider a small element having charge is dq and this length is dx, but this is a negative charge, so definitely the force df will be this directions. Yes, if this is df in this directions, in this exactly element, what we'll do here, the force will be df will be this directions. The student have to be think about these things. This is d theta and here the dx and charge is dq. I am preferring a small charge. So due to this, what will happen? A torque will generate at the center point. A torque will be generated. So definitely it will be rotate like this. This one will be what? Definitely due to torque it will rotate like this. Yes. So this scenario is pretty clear to everyone how this torque will be generated. So I'll write my net torque equations. So if I'll consider only upper half sections, if I look at this upper half sections, I'll write the d tau. D tau can be written as force into perpendicular distance. What I'll write? Force into perpendicular distance. This is df. And what is my perpendicular distance? This is the perpendicular distance to the force. This is the perpendicular distance to the force. If this is r, can I say this is r sin theta? Yes. So df r sin theta. This is expression is pretty clear to all. And df can be written as electric field, that is E naught, because E naught electric field is supplied, into dq. Yes, into r sin theta. So this is E naught. dq can be written as what? Lambda dx. And this is r sin theta. And it is obvious that E naught lambda dx can be written as r d theta, r sin theta. If you observe very carefully these sections, this is your dx, this is your r, this is your d theta. Angle equals to arc upon radius. Using that concept, I will simply write this is E naught lambda r square sin theta d theta. This is my, in the upper half sections for a small element, this much of torque is generated. If I integrate these things, I will get the upper half section, the torque. So what should be the limit? It can goes from 0. Here if I'll consider the element is here, this angle is 0, and maximum it goes 0 to pi by 2. Maximum it can goes 0 to pi by 2. Just put the limit 0 to pi by 2. This is E naught lambda r square sin theta integration is minus cos theta. This is 0 to pi by 2. If I'll interchange this limit then this negative sign will be vanished. So this is definitely, this is cos theta, this is 0, this is pi by 2. So what is the expression is coming? E naught lambda r square. This is cos 0 minus cos pi by 2. I hope the scenario is clear to all. So what is the expression is coming? The expression is coming, this is E naught lambda r square, cos 0 is 1 and this is 0. So expression of E naught lambda r square. I hope this small derivations of this integration, all these things is very common. A student must have to be follow these things. Acha. This is the torque in the upper half sections. Due to symmetry, the same torque will be generated in the lower half sections. So the net torque generated, you can say 2 into E naught lambda r square. So how much torque will be generated? This is 2 E naught lambda r square. This is the net torque will be generated. I hope these questions conceptually it is very good questions and give you a good level of thinking. So due to these sections the torque is E naught lambda r square. Due to symmetry I can say this section also the same torque will be generated. So net torque will be generated the 2 E naught lambda r square. Now I will write my equations. Very carefully a student has to be think about it. See, very carefully if you think about this thing, the torque will be generated like this. Due to this torque, the whole thing will be rotated in rotated in clockwise direction. This is your clockwise direction. When it will rotate like this, the friction at this section will be act like this, because at this section it goes like this, friction will be goes like this. So if I will write my expressions, let me redraw these things. At the center of the ring, the torque will be like this and friction exactly act like this, because when it is rotate like this, friction will act this directions. The friction will be act like this. I know the expression of the, I will write my rotational equations. So what I will write? Torque due to electric field. This is the torque generated due to the electric field at the center point, minus friction. This is my friction and this is my perpendicular distance r. Net torque equals to what? I alpha. I is what? I into alpha. Acha. Let me think first thing these things. Electric field equation is what? 2 E naught lambda r square minus F into r equals to I alpha. I is moment of inertia of the ring. Moment of inertia of the ring is mr square into alpha. This is first equation. I got it. And I already said this is pure rolling is happening. So I can use this equation that A equals to R alpha. This is the second equation. And one more equation I have to be used here, the translational equation. And what is this translational equation here? Very carefully. Translational equation is where only the friction is here, the giving rise this translational equations. So F equals to ma. Only friction is more this directions. So F equals to ma. This is the three things, three equations. Solving these equations, we can easily, you just put it here, A equals to what? R alpha. I just put it here. F equals to, substitute this A value here. This is mr alpha. And what is the expression of alpha? This expression of alpha equals to F friction upon mr. Substituting this value of alpha in this equations, equation 1, I can easily predict the expression of friction. What is the value of friction? Let me draw in a very faster way. So Fr, this is mr square, alpha value what I will substitute here, that is F upon mr. So cancel, 1r cancel. So 2e lambda r square is nothing but this Fr this side, this is Fr plus Fr. Yes, this is Fr plus Fr. So this is nothing but 2Fr equals to 2E naught lambda r square. So 1r has cancelled and 2 cancel. I will get the expression of friction, that is E naught lambda r. This is my desired result. A student has to be think about it. Let me one more time to analyze these things. If this is a ring, non-conducting ring having mass m, radius of the ring is r, this section is positive, this section is negative, and electric field E naught I, a constant electric field is switched on. This ring rolls without slipping. Question is asking, if the surface is rough, find the value of the frictions. If this kind of things have been given in the question, the student must think about first the torque, and I will write the torque from theta to d theta small element, as I preferred in most of my previous videos how to consider elements. So in that, using that concept, I write my expression of the torque, and upper section torque I got these things, and exactly this upper section torque I will get like this, and I know due to symmetry upper section and lower section same, so I will get the multiply a factor 2 here and get the net torque, and write what rotational equation, you can say net torque equals to I alpha. This is the way ring, so that's why I will introduce the moment of inertia is mr square. As pure rolling I using this concept A equals to R alpha, and there is another translational equation I said friction F equals to ma. Just little bit interchange all these things, I will get the desired value of the friction, that is F equals to E naught lambda R. I hope this scenario is clear to everyone. Let me do one more illustration for the student perspective that can help the student to think, uplift their level of thinking. Suppose this is a bob is here. Initially it was charged less, having length of the string is L. What is here? One infinite seat is here. This is an infinite seat. Very carefully you have to think about it. This is an infinite seat having surface charge density is sigma. Surface charge is sigma, and I will say this is non-conducting infinite seat. This is non-conducting infinite seat. This is non-conducting infinite seat. The question is asking, this is a bob having mass is m. Initially it is charged less. What is happened? We supplied the charge to this bob. When we supplied positive charge to this bob, this is positive, this is positive. What will happen? It will start repelling. So what will happen? This bob will be oscillate like this. It will be go like this. The question is asking, find the maximum angle of deviation of the bob. When you supply a charge, some amount of charge q to this bob, positive charge, it will definitely deflect like this. The question is asking maximum deflection. Maximum deflection. The question is asking what? Maximum deflections. A student, here the question is very simple. A student has to think one important thing is what? What is the expression of electric field due to a non-conducting infinite seat? This is very clear. If this is a non-conducting infinite seat, this is a non-conducting infinite seat, the expression of the electric field is sigma by 2 epsilon naught. It's a constant electric field, that is sigma by 2 epsilon naught, and the direction will be like this. In this section and this sections, the direction will be like this. So infinite thin sheet, that's why the expression of electric field will be sigma by 2 epsilon naught. So in this direction, what is the expression of electric field? That is sigma by 2 epsilon naught. Now this question has changed what? This is a charged bob and it is placed in an electric field of sigma by 2 epsilon naught, and it deflected to a maximum angle. Suppose it deflected to reach here. How much angle maximum it deflected? This is the question is asking. So when this kind of questions is asked to you, this length is L. When this kind of questions is asked, we must think about the normal procedure, that energy conservations, or you can say the work energy theorem. What I will use here? The work energy theorem. Work energy theorem. And what is work energy theorem says? Work done by all forces equals to change in kinetic energy, or you can say K final minus K initial. If you look at this section very carefully, how it will be moved like this? It will be moved like this. So here it stop. At this point its velocity is 0. That's why it is stop here. And this is the maximum deflections. And initially when it start, its velocity is 0. So can I say the final velocity is 0, initial velocity it starts from 0. So definitely final kinetic energy is 0, initial kinetic energy also 0. So here only the thing we will use here, that work done by all forces equals to 0. Let me think what are the work done here. Total length is L. This bob reached to this height. How much height it goes? If this is L, can I say this height is L cos, if this is L cos theta. So how much height it goes? It goes L minus L cos theta. A student has to predict like this. If this is L, this is your L cos theta. Total length is L. So how much height? You can say this height is L minus L cos theta. So work done by all the forces. Here work done due to mg, the gravitational forces. So mg is downward and it goes upward L minus L cos theta. So definitely this is minus mg L 1 minus cos theta. This is work done due to mg is what? At this point mg is downward and displacement, how much displacement you goes? You goes upward L minus L cos theta. Force this direction, displacement this direction. So angle between them is 180 degree. So F dot S minus Fs, so mgl 1 minus cos theta. And work done due to electrostatic, this is your force, electrostatic force. The electrostatic force is like this, that is sigma by 2 epsilon naught. And how much this distance it covered? It goes this much of distance. Can you say this is nothing but what? What you can say? This is nothing but L sin theta. So can I say work done due to electrostatic QE L sin theta? Yes. This is your electrostatic force into work done, electrostatic force into displacement. This is your electric field into charge Q giving rise to your force, and displacement is how much? L sin theta equals to what? 0. So this is very important. I'll put the value of E is what? Sigma by 2 epsilon naught with latter. So proceeding this fashion, this is minus mg. One can arrange this like this. So this is mg L 1 minus cos theta equals to, one can say this is what? QE L sin theta. Little arrange here, this L cancel. So what I are getting? mg upon QE, this is what? 1 minus cos theta upon sin theta. And I will substitute this value of E. This value of E is sigma by 2 epsilon naught. Simply I will substitute with the time. Let me solve this mathematics. So what is the result is coming? mg upon QE is equal to 1 minus cos theta. I will write the result here. That is mg upon QE. Little arrangement in a better way. mg upon QE equals to 1 minus cos theta upon what? Sin theta. This is mg upon QE. 1 minus cos theta trigonometric, that is 2 sin square theta by 2, and sin theta can be written as sin 2 into theta by 2. A little bit of trigonometric skill is necessary. 2 sin square theta by 2, this can be written as 2 sin theta by 2 into cos theta by 2. If you observe carefully, this 2 cancel, 1 sin square theta 1 cancel. So expression is coming sin theta by 2 upon cos theta by 2. This is mg upon QE. So expression is coming, this is tan theta by 2 equals to mg upon QE, and theta by 2 equals to, can I say, tan inverse mg by QE, and theta equals to what? 2 tan inverse mg by q. Here E value is what? Sigma by 2 epsilon naught. One can substitute. This is the desired result. A student has to be think about it. So what I said, I simply said this is a non-conducting infinite sheet. This non-conducting infinite sheet, a charged, positively charged bob is placed here. So what will happen? It will deflect like this. The question is asking find the maximum deflection. Due to non-conducting infinite sheet, the electric field will be sigma by 2 epsilon naught. That we already have to in your mind. So what will happen? It's simply a question like this charged bob in an electric field of sigma by 2 epsilon naught. I will use the concept of work energy theorem, that work done by all forces equals to change in kinetic energy, that is K final minus K initial. Initially the bob was rest and it goes to maximum deflection, means this bob is rest here, that's why the final kinetic energy also 0. So total change in kinetic energy is 0. Work done by all the forces, first work done by the gravity. If you look at the work done by gravity, this mg is downward and it goes L minus L cos theta. And work done by electrostatic, this is electric field into Q, that is force, and how much it displaces, L sin theta. Here one student also think about the work done due to tension. Tension, it is T is like this and displacement is like this. So exactly any instant if I look at like this, tensions and displacement exactly 90 degree. So work done by the tensions is 0, that's why I am not included here. And using the basic calculations, putting the value of E as sigma by 2 epsilon and little bit trigonometric skill, I reached to the conclusion like this, and this is the maximum deflections that we can find it. I hope this scenario is clear to everyone. Thank you everyone. Thank you for your watching.